First of all, I want to thank you for joining us this afternoon for the F450C panel discussion. We're going to have to pass this microphone back and forth throughout the conversation today until we get a second mic up and running. So that'll be a bit different than we had planned. Volume sounds good. My name's Todd Fossler. I'm the F450C Program Manager for M&W. And it's my honor to introduce you today our panelists. Dave Skilbred, he's the Director of the Program Coordination and Management for G450C. Ben Peak, he's an F450C Project Architect with Haas. Lothar Till, Managing Director with Ovivo, Switzerland. Paul Allers, Head of Product Management with Bush Vacuum, and Joe Barron, Head of Sales and Marketing, CS Clean Systems. So what we'll do is start off with the question that we think is on most attendees' minds. And that'll be directed to Dave. Dave, with the F450 millimeter uncertainty, what's the ongoing value in G450, F450 consortium participation?
Todd, thank you very much. You know, it's really great. I've never been asked that question before today, so I really appreciate that directness. I think I know most, if not all of you. Yeah, Dave Skilbert, Intel assignee, Program Director for G450C. I think the value proposition I'm pleased to announce is very positive. It's a very easy thing for me to answer. If you look at the cons, so to speak, G450C cannot speak for our direct member companies on HVM timeline. So I can't tell you today, is it 1 year from now, 3 years from now, 5 years from now? That's the only negative that I can see. And member companies will not speak to the press about a timeline. They'll be speaking with you directly when they're ready. Now, the corollary to that I can talk to, and I'm pleased to report, is the success of G450C as a consortium along with F450. To date, we have 52 platforms representing full process flow capability of a semiconductor logic factory. And that's the good news. Nikon, for example, has just arrived with a platform on the site in Albany, a full 450 wafer 193 immersion scanner. Wafer quality is exceeding M1 capability. Last but not least, the technology and the productivity of a 450 millimeter line is at the 85 to 90% readiness for sub 10 nanometer technology. So while we don't have a given member company timeline, we do have very strong results representing a full factory flow. And it's just a question of when, not if, for 450, in my personal opinion. So I think as of right now, this becomes much more of a global macroeconomic challenge than it does is 450 millimeter ready for prime time. I'm stealing just 1% of the thunder from our TechSpot presentation at G450C tomorrow, but getting to answer this question, we see a lot of very positive collaboration. All of the companies we work with are fully on board supporting 450 development work. All of them have maintained and generated 10 to 20 different benefits that help them in 300 millimeter and overall technology development that just tackling the 450 readiness question. So I think there's a lot of upside. I'll finish with the facility side, and we'll get into a lot of other questions today. But again, the playground, so to speak, or the sandbox in Albany at CNSE with G450C of full platforms and a full facilities support group enables us to collect and share data with industry unlike anything any given member company would normally allow access to. So that's the final end state. I'm excited with our F450 partnership of how can we collaborate wafer size independently on facilities innovations, not only for 450, but for the rest of the semiconductor industry.
Thank you, Dave. Thanks, Dave. Next question is for Ben. Ben, Haas has been working with both M&W and G450C to build an innovative, secure research database platform. Could you give us an overview of the agreement and explain the impact that it will have going forward in terms of using this platform to support the sandbox?
Thank you, Todd. The challenge, of course, in any semiconductor manufacturing facility is to collect enough information to make good decisions. And as you may know, Haas is providing effluent monitoring systems to the G450 fab in Albany. And one of the challenges that I had very early was how do I work from Reno or Portland, Oregon in Albany and have access to the data. And so early on, about a little more than a year ago, we began to work with G450 with David and with Paul Kelly at the College of Nanocell Science and Engineering to try to sort out how we could create a data collection environment and a platform that could give the tool vendors access to their data from anywhere. As an example, Nikon from Tokyo, perhaps, in looking at their information, or for us from Reno, or Sparks, Nevada, or Portland. So after going through all of the proprietary agreements and really understanding how this could be accomplished, we convinced Paul Kelly at CNSE and G450 to really own the platform and for the college itself to monitor and manage the cybersecurity issues that come up for any particular vendor. So we now have a platform. It's comprised of servers, firewalls, network switches, etc., that would allow any particular vendor to have access to their data from their own office or whatever over the internet. And I think for those of you in the semiconductor industry for years, you know that getting to proprietary data or sharing data across an infrastructure is not done very often. And so that's what Haas has accomplished with our data collection and research platform. Thank you.
Thank you, Ben. Lothar, sustainability and resource conservation are factors that engineers and leadership need to consider strategically and tactically when making decisions for a fab. What are some of the developments and achievements the consortium has seen in G450C and within member companies' R&D efforts around water conservation and waste stream segregation at the tool, and what are the impacts for 450?
Thanks, Todd, and I can just say the impact is huge. As you can imagine, moving from 300 to 450 millimeter, you're doubling the wafer size, and basically you're doubling also the water consumption that's needed to rinse those wafers. So from our perspective, the first thought we had is great, systems are getting bigger, we're making more money. But I guess our customers are not really keen to get that answer. So for us, in order to reduce water consumption, I don't see any chances that this can happen on the tool level. When getting the experience out of CNSE, we can see that moving wafers up and down takes too much out of productivity. Waste segregation would be an issue. What we are focusing on right now is how can we reclaim some of that wastewater, bring it back in the process, reduce the overall consumption of raw water, and reducing also the waste that goes down the sewer. So here I think Ben will also talk a little bit about waste segregation later on. Now for us, we have to of course assume the worst case scenario, and that would be that we get I would say a toxic cocktail of wastewater out of the fab that's coming down, and we have to find ways to treat this cocktail. We are working on different processes, either membrane and biological combination of processes to reclaim some of that wastewater, bring it back into the pre-treatment for the ultra-pure water system, or use it elsewhere in the fab, being it for scrubbers or cooling towers. We are also doing quite a bit of research now on treating the actual effluent waste We see a lot of phosphor, fluoride, sulfur in that wastewater. We are working on precipitation and crystallization processes to actually turn this into solid waste. And that could either be sold back to the chemical producers and turned again into phosphorus, hydrofluoric or sulfuric chemicals, acids that can be used in the fab again. After all, these are pure ingredients that have been through quite a bit of a cleaning process by using it in the wafer fab, so that should be not an issue to be reused again. So here we see some potential in actually reducing the economic impact and also the ecological impact of moving to 450. After all, it's not really a question of the wafer size, but it provides us now, this consortium, a good platform to study technologies, processes that can be used for 450, but also for other wafer sizes, I have to say. Thank you.
Thank you. Okay, next question, Paul. Major focus in today's fabs is power management. Vacuum and pump systems consume a lot of space, a lot of energy. What are some of the key design attributes a company should consider when engineering products for today's process technology demands in a 450 future?
Thank you, Todd. Obviously, we try to save energy, go down in footprint, but we listened very carefully also to our end users, and they came up with a big worry. If you keep changing things, you're introducing risk. So we needed to find that great compromise between having proven technology which has reliability where people can count on, not losing cost because this newest, greatest reduction in space and energy on a pump all of a sudden fails and then introduces very expensive cost of repairing all of that, combined with a strong drive of still getting energy benefit. Now that has been a very great challenge. We already had at Bosch the real reliable pump design, the twin screw, which is really one of the best designs you can have for harsh duty pumping, but it does consume a bit of energy. And you might not want to spend that energy as soon as you get to a lighter or medium process. Now that challenge we solved recently with a new technology we call actually premium efficiency. And that new technology actually makes the compromise without making a compromise. What we do is we actually keep all the benefits of this twin screw design with the proven MTBFs we have from it, and added to that a non-invasive technology which does not impact basically the main pump's function, but reduces the energy. So now you get the best of both worlds. You have the proven reliability, which is really the first which our customers ask for, combined with great energy savings we are obviously looking for in today's industry. And I think that innovation came out of listening very carefully to also all the members of F450 and G450, and that drive really is one of the major innovations coming out of working in consortiums like this. So we're really proud of introducing that premium efficiency, proven technology, reliability, combined with energy savings. That is a major step for us. Thank you.
Thank you. Okay, Joe. Companies such as CS Cleans have focused R&D efforts on technology and innovation that's scalable with different wafer sizes. Can you speak about the importance of scalability in today's processes and tools, and how does that scaling technology development across wafer sizes prepare us for a transition to 450?
Thank you very much, Todd. 300 millimeter and 450 millimeter technologies are going to converge at some point, well, at least at the larger IDMs and foundries. You know, when that happens is anybody's guess, certainly, but it's going to happen by all accounts. Just to begin with 450 millimeter scaling, the main motivation for moving to 450 millimeters is to make the same number of chips using a largely reduced tool set, maybe half the number of tools with larger chambers. Okay, so while we don't know, we don't have all the answers yet. I mean, a few things are fairly predictable. One thing that we can assume is, or if we assume that the same number of chips are going to use the same amount of gases, the same amount of chemicals and materials, and then if we go back to the point that only half the number of tools are being used, what we see is the logical ramification of that is throughput through each chamber is going to be doubled, or maybe more than doubled. Okay, so that's going to put a large strain on pumps, on exhaust lines, chillers, abatement systems. That's one aspect. Another aspect, and a very crucial aspect, is as the industry moves to 450 millimeter chambers, you're going to concentrate the product into fewer tools that are more expensive. Okay. So what does that mean? That means that tool uptime is even going to be more mission critical than it already has been. Or putting it in another way, a minute of downtime is going to be much more painful at 450 millimeters than it is at 300 millimeters. So the logical consequence of that is the demands on the tool makers are going to be, for reliability, are going to be much higher. Tool vendors are going to be judged much more strictly on reliability of the tools and the uptime that the tool gives to the semiconductor manufacturing company. If we move over to 300 millimeter manufacturing and the scalability there, okay, you've got your 3D stacking, that's scaling. You have your scaling from 20 nanometers down to towards 5 nanometers. A major development, besides the scaling itself, is the chip makers are going to need many elements from the periodic table that are not available as gases. So you're going to see a continuation of the trend, a little bit away from gases towards organometallic liquids, exotic materials. That in itself is going to place challenges on vendors like us, like CS Clean Systems, that make abatement systems. Okay. Apart from the transition to liquids, you're going to see different tools coming into the tool set. There'll be a tendency for less CVD tools, more ALD tools. You're going to see, unknown tools like MOCVD tools coming into the tool set. So, just purely from an abatement point of view, what we would kind of argue is that differentiation can play a role here. You don't have to, just like Paul said about the pumps, you don't need to choose the same pump for each process application. You need the pump that would do the job efficiently, more than good enough, but not completely over-dimensioned either. And that's a very, very key point to abatement systems, where you've got completely different technologies. Some of them are very electricity intensive, but don't create any wastewater. Some abatement tools are very, very, they produce thousands of gallons of wastewater every week. Then you have other abatement technologies like dry scrubbing, that don't use any or almost any power, don't create wastewater, but at the same time are not applicable to all process applications. So differentiation will become a key factor as the industry scales down and moves to different process technologies.
Thank you. So this would be a good opportunity to take a couple questions from the audience if anyone has one they'd like to ask now. Otherwise, we'll continue with the questions here. All right. Okay, Dave. You mentioned that a new Nikon tool, the N193 immersion. So looking at the 450 millimeter equipment investment in the campus, you've got essentially full fab process flow. What are your thoughts on operational readiness and next steps for the sandbox?
Thank you, Todd. Yeah, actually, I'm very bullish about fab readiness as it relates to G450C in a very large partnership with our member companies and especially SUNY CNSE for the site. Technically speaking, the fab is online now. We keep adding more platforms every quarter on quarter. The 193 immersion tool will have wafers run through it as early September or late August. In addition to the wafers we've already been running for a year in Japan, in Kumagaya. So that's just the latest breakthrough for online success in Albany. We will effectively have a full fab capability of each unit process flow in Albany by the end of the year, at least one of a kind, in many cases two of a kind. All of that is automated, so we're measuring and testing the standards that are world-class 300 millimeter. In some cases, some innovations for communication and automation going forward in 450. Wafer and carrier standards are alive and well, and we feel in many cases we are HVM ready for wafer quality, already exceeding M1 capability for lithography today, and carrier standards going very well in practice from multiple suppliers. We then get into, again, the sandbox of our partnership with F450. Just to name a few, as many of you are aware, off the top, we have green mode initiatives with Edwards and other companies that are not only 450 related, but a very good showcase with the tools we have. We have large amounts of data collection partnering with Haas and others of, really showing that 450 is meeting or exceeding the environmental requirements in consumption versus 300 millimeter unit for unit, which is a key initiative the member companies are driving for 450. Ergonomic solutions, airborne molecular contamination initiatives with EMI, Fraunhofer, and our friends at Dixon, who I believe are hiding in the back over there. So just to name a few of the standards that are not only good for 450, but also for technology and wafer size independent. Unique abatement solutions, water purity. So the list goes on and on. So I think the answer is the factory is ready now, and unlike maybe past wafer size transitions, the value proposition for G450 and F450 is how can we help the supplier community innovate and showcase innovations that are breakthroughs, not only for 450, but industry productivity and improvement.
I want to do a little bit of a plug for the data collection platform by saying that it's very interesting in talking to people in the College of Nanoscale Science and Engineering. I asked the question of why do we not have more graduate student researchers in the fab? And the question was answered with, they can't get in, there's no access. And so as you can imagine, having a platform that gives people internet access to a tool means that even academic research, and it doesn't necessarily have to be at CNSE, but that kind of research can occur in this sandbox. And as you can imagine, this is a unique research platform. There are billions of dollars invested in this tool set, and it's not just pertinent to 450 millimeter wafers, but in fact, most of the research that can be done is applicable to the industry in general, whether it's 300 or even 200 millimeter wafers. And then with the F450 membership and the G450 membership, we can invent research projects now in the sandbox that were not possible even recently. And to give you an example, we could correlate the data from Bush with the data from Haas's collection of energy data across the fab, or fluid flow data across the fab, and then have a much better feel for how the entire fab works as a unit, which I think is extremely important and something that has to be quantified better than it is now. So thank you.
Just getting back to the data collection, I think it's a very, very important step because it actually opens the door to another worry we got from our end users, which is, can we predict by intelligently analyzing this data if we're in for a major fail event, and typically 5 to 10 minutes before it actually happens. That usually is enough to go to a safe situation, which then avoids major damage. So I think this data collection will be key to learn enough things to be able to pull that off, and that would be again a major risk and cost saving for actually abroad all the technologies, not only 450 but down to 200 millimeter as well.
Thank you. All right, I'll kick this one off with Dave again. So, Dave, in March, the Israeli consortium called Metro 450 Consortium signed an agreement with SUNY Poly CNSE, home of the F450 G450C, to develop critical tools for the industry's transition to 450. G450C's Pinyon Lin administered the closing keynote at this year's Confab. Tomorrow, SEMICON West is hosting a session on industry status of 450 millimeter. I'll lead off with Dave, but I'm going to ask each panelist to take a minute to talk about why they and the member company they represent are optimistic about the overall industry and the 450 transition.
Yeah, I was going to say, I think most of the panel members were asking me some of this before the panel started, so I can start. I guess the way to begin this, without repeating too much of what I've said earlier, number one, what I'm very happy about with G450 and F450 is our strong partnerships with global worldwide industry. From the beginning, we sought to not duplicate efforts, eliminate redundancy with the rest of the semiconductor community on 450. So very strong partnerships with EMI, Metro 450, as Todd alluded to, IMEC, among many others in Japan, Europe, and the rest of the world. So those partnerships continue on collaboration and standards. The advent of 450 as an initiative led to how we can help suppliers, and led to things like pure notchless standardization, which is now the standard for 450 millimeter, and 1.5 millimeter edge exclusion, which just successfully passed in the last month. So those are a couple of things that we've brought about with 450 millimeter to date. In terms of optimism, I clearly can't say when, but I can say 450 millimeter is clearly one of the very few ways to offset and reduce costs of a very rapidly increasing R&D cost environment as bleeding edge node to node becomes more challenging in both time and money spent. So I think that's one positive we see together. The challenges are being overcome much faster than I think industry thought if you would ask 5 or 6 years ago. I think most of the supplier executives in the community would agree, out of the gate, 450 millimeter technology happened about 40% faster in the first year or two than we expected. A lot of that might make sense, right? The automation is already there. Some of the rudiments of the ergo infrastructure are there, as opposed to the last wafer size transition. But the technology, the suppliers have been really good at this type of a transition and development. As I alluded to earlier, we're about 85 to 90% ready for sub-10 nanometer productivity and technology today. So that's pretty exciting. So I guess in conclusion, the current G450C model for industry is be ready. We're aware right now the priority is 300 millimeter. We want to be within striking distance for when member companies are ready for 450 HVM prime time. That 18 to 24 months, and we believe we're ready there now. So really to finish, the continuing message from G450C on behalf of our executives, F450, and the supplier community is, how can we help you? How can we help your business? We're open to feedback of how to make 450 millimeter better, and concurrently with that, improve standards and productivity for industry, wafer size independent as well. Thank you.
Well, what does this mean to the Haas Corporation? We're doing a fluid monitoring and data collection, and I think for the very first time, the 450 research platform, all of G450 and F450 combined, gives the industry itself, and certainly Haas, the opportunity to think totally new thoughts, perhaps to look at performance, chamber to chamber on process tools, and characterize those very accurately as a part of tool install and tool setup. And that's not been possible up to this point. I think as well you can imagine looking at a manufacturing process end to end, and with a data collection platform and many different people providing data to that platform, we might be able to test out the concept of default management or yield across an entire manufacturing process. And I think that would be something that has not been attempted, certainly not across a whole set of tools before. And so I think that finally, from the Haas perspective, the real opportunity for us also includes the opportunity to actually be involved in and perhaps drive standards for things like water recovery, things like chemical abatement, and what do you do with effluent from a tool, and water recovery in particular would be extremely important regardless of whether you're 200, 300, or 450 millimeter. Thank you.
Thanks, and I'm also happy about David's optimism. We heard a lot of negative talk about 450 also in the past, we have to admit that, but I honestly believe if a technology is available, and we have heard that it's available now, then it's only a question of time when it will be used and not if it will be used. We have seen that in the past in other technologies, and I'm pretty optimistic that 450 will come. What it means for us, water conservation is a big issue. These fabs are monsters, they consume a lot of water, and the way to recover and to reduce, this is where we have to go. It gave us an opportunity to better understand the needs of the industry. We are also proud that we are involved not only at CNSE, we commissioned a new UPW system last month. We are building one right now at IMEC. So I think for the two 450 millimeter sites, we are already involved. And our goal is to actually improve what we see in existing fabs. We have 70% water conservation or water recovery rates now in 200 or 300 millimeter fabs. We want to achieve a minimum of that, if not go higher to probably 90%. It takes some data that we get from the fab to see what is coming down for the waste pipe, how can it be segregated if possible. If not, what do we need to do to treat it properly, to recover as much as possible. Here I can say technologically almost anything is possible. Maybe not everything is reasonable. We have to see what makes sense, what does it cost, how can we work together, and the consortium I think is a good platform to learn all of that. So I'm positive, 450, we are ready.
I'm positive as well. It's actually a great opportunity. Going for a new level of wafer size opens also the possibility, and we took that possibility at Bush, thinking out of the box. Like Joe already said, it becomes increasingly more expensive if you have failures on such tools. There are less tools, downtime becomes more expensive, so that actually pushed us to think out of the box. Think reliability first, but still needing to do something about energy saving, water saving, all of those important elements. And that drives you to innovation, and I must say, 450, that contributes a lot to that. So that is why I think it will be a success. It drives innovation, and innovation leads to success. That's why it's so important to us.
Yeah, one interesting new term, or that we all kind of had to ask David a little bit about earlier today, was the sandbox. And we found out that what he meant by the sandbox was it's kind of a playground to some extent. But maybe playground is a bit too jovial, but certainly the consortium gives the vendors and the tool makers the opportunity to experiment, to optimize things, to make mistakes, while mistakes are still reasonably cheap, you know. So we're positive about that. From the point of view of CS Clean Systems, a critical contribution we can make, you know, we've heard a lot about wastewater generation and conservation, and you know, there's a parallel event running today about sustainability. A key contribution we can make, you know, at CS Clean Systems as a company that focuses on dry scrubbing is we can prevent wastewater at source. Okay, we can't do it everywhere, but there are a lot of applications, processes in a fab where we can put abatement in there that doesn't use any water at all. So we're not even, we're preventing the problem at source. We're not trying to deal with it, afterwards. Just to summarize, I'm positive as well. I think the semiconductor manufacturers themselves don't have the transparency at this point even to know when the transition exactly will occur. Clearly, it will occur when it's more economically attractive to make the leap from 300 millimeter to 450 millimeter. But the economics suggests that it makes sense, and at least for the big players, it's going to happen. It's not a question of if, but a question of when. Thank you.
Thank you. Okay. Panel questions? Any questions from the audience? All right. I know it must be between you guys and happy hour. All right, so let me thank the panelists for their participation and traveling out here to support the conversation today. I appreciate it. We'll be around for a little while afterwards, so if you'd like to have offline questions with us, we'll be here. All right, thank you.